Hi guys, this is Kushbu and welcome to Algorithms Made Easy. In this video, we'll see the question triangle. Given a triangle array, return the minimum path sum from top to bottom. Now, the condition over here is that for each step, you may move to an adjacent number of row below. If you are on index I on your current row, you may move either to index I or I plus 1 on the next row. So that's how you can move. Here are two examples given to us. Let's see one of it visually so that we can better understand the problem. So here is the triangle that was given to us in the first example. And if you mark the path a cell can take, these would be the paths it can move. For example, this cell at row 0 can move to the row below it at index 0 and 1 because this 2 would be at 0th index in the list given to us. Now, this 3 is at index 0 on row 1 and it can move to either index 0 or 1 on the next row, that is row number 2, considering the row starts from 0. Similarly for the other cells also. If you see this is something similar to Pascal's triangle, wherein you can move in these steps and you have a condition on which you will be moving. That is, you need to give the minimum sum. So you need to select the minimum of the corresponding values wherein you can move. So in this example, you can move over here to get the sum of 11, which is your answer for this particular example. There can be two approaches to solve this one. One is top down, that is, you go from 2 in the levels below, and the second is bottom up, wherein you start with the last level and you move up towards this 0th level. So we'll see both of them in this video, starting with the top down approach. Now, we'll start with level number 1, and over here the value that can come to 3 is from 2 only. So we need to add 2 to this 3 to get a sum of 5 over here, and the sum for this particular cell would become 6. That would be the minimum sum for that path considering 2 and 4. So these were the corner cells and does not need to take the minimum into account because there is only one number that we are considering. Now when you go down, these corner cells again only can sum up from their above cells, which is this 5 and this 6. And that give us 11 and 13. But the middle cell would contain the minimum of 5 or 6 because this 5 cell can also go to this 5 cell and this 6th one would also be able to move over here. So we need to take the minimum of those into consideration while calculating the sum. So we take this 5 and we sum it up, and this gives us 10. Again, when we move down, the corner cells would have the sum for the one above them for the first index and the last index. But when you go to the middle ones, there is a possibility to come from two of these cells to this particular cell. Even for 8, you can come either from 10 or from this 13. And so you select the minimum sum from them. And this gives you 11 and 21 over here. So now this last row is giving you the sums from different path. And amongst those sum, 11 is the minimum one, and so it is our answer. So as you can see, we are going to go and take the corner cells case and the middle cell case. So that's what we are going to do in the code, and after coding we'll see the bottom up approach for this problem. So over here I'll have to loop on the rows and columns. So I'll have a nested loop, and for the row I'll start from the first row instead of 0th row. So here's our nested loop. Now we'll take a integer variable sum that would store the sum at that particular moment. Now we have three cases. The one is whether we are at 0th column, whether we are at last column, or whether we are in the middle ones. So if my j is equal to 0, my sum would simply be the sum of current number plus the number from the row above it in the 0th column. Now comes the condition wherein my current column is equal to the last column of that row. So over here also, the sum would be the sum of the current row column plus the last cell of the row above it. So this is the current cell and this is the last cell of the row above this particular current row. Now, in all the other cases, I'll have to take the minimum from the above row. Now, which cells from the above row? From the above row, I want the column I and I minus 1. So let's take a minimum wherein we'll have math dot min of these two values, that is I minus 1 and j, and I minus 1 and j minus 1. And now my sum would be equal to minimum plus the current cell. And this would be triangle. And now after we have done this, we need to set the value we have in sum at the current position. So we do triangle.getI.set at jth column. I need to update the sum. And finally, I'll have the sums for the path in my last row. And from that, the minimum one would give me my answer. And that's it. Let's run this code. And we are getting a perfect result. Let's submit this. And it got submitted. So the time complexity over here would be O of n square, where n is the height of the triangle, because we are going to go to each and every cell of that particular triangle, and the number of cells that are there in that particular triangle would be n into n plus 1 by 2, and that gives you O of n square time complexity. Now the space complexity for this problem is O of 1, as we are updating the same array that is given to us. Now that we know the top-down approach, let's see how bottom-up approach works. So, in the bottom-up approach, we'll have an inverted triangle. And from here, I am going to go down from top, taking the same conditions in mind. So, if it were an original triangle, from this 7, I could have gone to 3 and 8. From 5, I could have gone to 1 and 8. From 6, I could have gone to 4 and 1. So, now since we are reversing it, we are taking it in the inverted manner, that is from 3 and 8 we can go to 7 and so on. So over here my value would change to minimum of these two values plus the value at this cell. Similarly for this cell it would be minimum of 8 and 1 plus 5, and similarly for 6, which would give me this result. Now we'll go again one level below, and over here also we do the same, and this time the values get updated to 8 and 9. Similarly, when we come down to this particular cell, it would be minimum of 8 and 9 plus 2, which gives us 11. Now in this approach we are going to get the result in the single value that is there, and we are not having any corner cases over here. So we always have to compare the values from the two sources from which we can come to this particular cell. Rest everything still stays the same. So let's go ahead and code this particular approach out. And over here again we'll have the nested for loop, but that would start from size minus 2 and would go up to the 0th row. Over here I am simply taking the minimum of two values which are there in the previous row, or in this case it would be I plus 1th row, and those would be from column j and j plus 1 this time. Now my sum would be minimum plus the current cell's value. And now I need to set this sum at the current cell. So I'll set at column J the sum that we have calculated. And finally, my result would be in the 0th row and 0th column. And that's it. Let's run this. And we are getting a perfect result. Let's submit this. And it got submitted. So the time and space complexity over here still remains the same. Now, there is a follow-up question that an interviewer can ask you, that what if I say you cannot update the original array that was given to you? Now, what if the interviewer says that you cannot update the original array and the maximum extra space that you can use is O of n, that is the height or the total number of rows in that particular triangle that is given to us. So I like you to solve this follow-up question, and if you get any problem in that, let us know and we'll make a video on that approach. So that's it for today, guys. I hope you liked the video and I'll see you in another one. So till then, keep learning, keep coding.